Okay, so we're going to go over this. This is 1.3 alpha, and you're going to need to have your calculator. So if you don't have it right in front of you, reach for your calculator. We're going to do some things on there that we need you to follow. So first thing is, yesterday we did measuring the shape, and we talked about skewness, whether something was symmetric, some shape of some univariate. Univariate means one variable, the prefix uni, one variable, versus bivariate data, which would be something that you would graph on a set of axes. But univariate data, we talk about the shape. So it could be symmetric or it could be skewed. And that was in 1.2. So today we're talking about the center of the distribution. So one way that you're familiar with this measuring center is the mean. So the mean is abbreviated X bar. But here's the algorithm. Does that make sense to you? Can you read this? You've got the Greek letter sigma, which is telling you the sum of what? The sum of these elements, beginning at the first one, I equals 1, x sub I, beginning at 1 and ending at n. So that's x sub 1 plus x sub 2 plus all the way up to x sub n, divided by how many elements you have. There's the mean, which actually takes something you're familiar with and makes it much more complicated, but you have to be able to read that. Another way to measure center, other than the mean, is the median. So the median comes from, if you do a box plot. So a box plot, we have the left, and then the box itself is Q1 is one edge of the box, and Q3 is the other edge of the box, and the median Q2 is in the center. Then you have the max. And the data is distributed 25% in each quartile. Now, if the data is symmetric, then the mean and median will map onto each other. But if the data is skewed, look what happens. If the data is skewed to the left, if it's skewed to the left, that's where the tail is. So if you have some values to the left, which, we'll talk about, I don't want to use the word outlier because we haven't quantified that yet. But you have some values off to the left in the tail, what's going to happen? It's going to bring the mean with them. So the mean will then be less than the median. If the data is skewed right, that tail is going to bring the mean with it, and it's going to be greater than the median. And the reason that is because we say that the mean is sensitive to outliers. It's sensitive to big numbers. Whereas the median is resistant to big numbers or small numbers. The range, max take away min. All right? And then we've got standard deviation. So standard deviation is a measure of variability. It's a measure of spread. So yesterday we told you about that prompt, and the prompt is describe. Ready? AP says to you describe, and it's univariate data. You say center, shape, spread. But if you're not focused on this, and we get to May, and you write some flowery paragraph about describe, you're just wasting everybody's time. It's not a language arts class. Get to the point. Center, shape, spread. Compare just two distributions. You identify, you quantify the center, shape, and spread of each of them. That's what it means to compare them. So standard deviation, the textbook refers to variability as opposed to spread. Standard deviation is one way to measure spread. So you have to be able to read this. So the standard deviation is, we go inside the root sign. the sum of how far each element is from the mean. We're going to square that, divide by 1 less than the number of elements in the set, and then take the square root. Now, one thing should seem clear to you, like you're squaring this in here, and then later you're taking the square root to undo what you've been done. But this isn't clear. Why would I divide by n, take away 1? This is for the sample standard deviation. When you don't know which standard deviation to use the sample. It's the default. The only time you use the population standard deviation is if you are confident that you have every element of the data set. So for example, when I show you the AP scores from the spring, College Board publishes the standard deviation. That's the population standard deviation because that's based on every test taker. But the point of statistics is to make an inference about the population from a sample. Like we don't want to have a census for every time we're looking for some data. So the thing right now is polling, and you'll see all this polling about the election. If they couldn't publish a poll unless they talked to every person who planned to vote, there would be no polls. So what they do is they make an inference from a sample of likely voters or a sample of registered voters. They're two separate polls. So anyway, we divide by n, take away 1. Now think about what that means. If you divide, if your denominator is smaller, this denominator is smaller than that one, then the value of your fraction is going to be larger. So this will always be bigger than that. The sample standard deviation will always be larger than the population standard deviation. And the one way to think about that is, well, I don't have all the data set. So I'm building in a little cushion here for my measure of spread. Now, that's not technically why, and we will quantify for you why you specifically divide by n, take away 1, because, you might say, well, if I divide by n, take away 2, I build in a bigger cushion for my step. You're right, but there's a specific reason that we divide by n, take away 1, and we'll get to that. So let's go here. Let's go to your calculator. And let's go to the data set on where am I? Let's go to the data set that is on page 61. It says, how many friends do people have? So there's a couple ways to do this, just so you know. I put the data set on page 61 into list 1. So there's 11 people replied. We good? And there's a dot plot there. One person said they had 1 close friend, and then one person said they had 6 close friends. Everybody else was in between there. So you could just list them all right here. Or you could do this. 1 friend, 2 friends, 3 friends, 4 friends. Now we could put 5 in there, but nobody claimed to have 5 good friends. So we'll put it in there anyway. 5 and 6. And then we could go to list 4 and do a frequency. So we could say 1 child had 1 good friend. 1, 2, 3 kids had 2 good friends. Understand what we're doing? From on page 61, it's how many dots are above those numbers. 3 good friends. 4 children said that. 4 good friends. 2 said that. 0 said they had 5 good friends. And 1 child said they had 6 good friends. So that is 4, 8, 10. That's the 11. Either way works. You can put all the points, all the data points in a list, or you can do a frequency in the next list over. Now, if it's a large data set, you want to do it like it is in 3 and 4. But you don't have to. So I've got this in list 1. So now I'm going to go here. We're going to start at the end. Second quick. Stat, calc. 1 variable statistics. Well, I have it in list 1. So I push calculate, and it gives me all this data. Ready? The mean's 3. The sum of the friends is 33, close friends. Sum squared. S of x, this is the step, standard deviation. The Roman letter is telling you sample standard deviation. This is a Greek letter. It's a small k sigma. The Greek letters used for population. That goes for the whole course. If you see an abbreviation and you're not sure, Roman letters go with the sample, Greek letters go with the population. But what do you notice? The sample standard deviation is a little larger than the population standard deviation. So I could do that, or I could do this. Stat, calc, 1 variable statistics. I put them in list 3, the friends, and I put the frequency list in list 4. And you get the same answer. You get all the same data. So you could do, that's what the frequency list is. And if we go to stat edit, if you're prompted for the frequency list and you didn't use it, you didn't use anything as a frequency list, then leave it empty. Okay? So what happened? We got those numbers. So I'm going to do this. I'm going to go to stat, calc, 1, just to remind you what those numbers are. And I've got this and this as the measure of step. So the sample standard deviation was a little over 1 3/10, and the population was a little less than 1 3/10. So we're going to do this now by hand. We're going to do it a long way to show you where the number comes from. So when you get to follow this, it's kind of like when you did limits in calculus in order to understand derivatives. And once you understood how to do the differentiation with the limits, you didn't really do it that way. You used the power rule or some other method of differentiation, but you had a foundation for why that worked. So I go to stat edit. I'm going to do it the long way. We're going to use list 1. So we're going to go over here and we're going to say second 1, subtract. Now we know the mean's 3 because we did that. If we don't know it, we could go second stat, over to math, 3, the mean of list 1. Well, you're going too fast. Like, where did you find that? All of the stuff, all the commands in the calculator are in the catalog. So if you don't remember where to find mean on second stat, just go to second catalog and everything's alphabetical. So I know that I go fast on the calculator, but push enter. This is how far, ready? 1 is 2 below the mean, because the mean was 3. Now if we go here, second quit, well, let's go here. Let's go second catalog. I want the sum of list 2. When you're in catalog, you can't see it here. I have to move this. See this alpha symbol up here? The calculator automatically puts you in alpha mode. So I just scroll down to T, and then I'm going to back up to sum, because sum's going to be closer to, all right, there's sum. Enter sum of second 2. What's that going to be? It's going to be 0. It's going to be 0 by definition, because that's how it is to me. Does that make sense? So the point is, when I go to stat edit, list 2 is no good to me, because it all adds up to 0. But that's implying to you that every value is 3, and it's not. So one way to deal with that is you could square this. So I could go to list 3 and type second 2 x squared k. And we squared list 2. Now what? Second quit, second enter, I'm going to do the sum of list 3. The sum of list 3, and I'm going to divide it by 10, because there were 11 entries in the data set. And we're going to divide by n take away 1, which for now, you're just taking my word for it. You push enter. Take the square root of your answer, and it's going to give us that number, which is a little higher than 1.3. And if we go second enter, and we divide by 11, and take the square root of that, I can't see what I did. That might not work. There's a number that's a little less than 1.3, because that would be the population step. So the issue is the calculator is doing it for you, but you have to know what the calculator is doing. So we're going to do a couple problems. So let's do a couple together, and then we'll send you to a couple problems, and then you'll check out with one. So I'm on page 75. If we look at 87, ready? It says Joey's first 14 quiz grades in a marking period were as follows. You're not going to do this, just look up here. So I put the 14 quiz grades in list 1, and I calculated the mean. And I turned around and showed you what happened. Here's each of the grades divided by 14, same number. And what happened? Joey had a bad day, and on the 15th quiz, he got a 0. So the 0 doesn't add to the total, but you divide by a greater number, his average went down. Why? Because the mean is sensitive to outliers. This 0 is an outlier. It's a lower test score than he's used to, and that drags the mean down. That's the skewness. For 89, it says, find the median. Well, look what happened. the median for his first test grades mapped onto the mean, 85 and 85. But the median, when you put the 0 in there, only dropped from 85 to 84 because the median is resistant to outliers. So you're going to use that data set to go to 97 is based on that data set, and then 99 is a different data set that asks you to do standard deviation. All right, so you're going to go over those, and be a few moments, and one of them will be the exit ticket. All right, we're going to come back to this, and I just got a question on the chat, so I'm going to address that to everybody. And the question was, how many decimal places? So in calculus, College Board's very specific. They want you to take things at 3 decimal places. There are no guidelines for statistics. So under the circumstances, my recommendation is we do what we did in calculus, and we take it at 3 decimal places. But just so you're aware of it, if you took something at 2 decimal places, it wouldn't automatically be penalized like it would be in calculus. So, I mean, we did that class, we accomplished that. I think I would just stick with what worked. So we're going to go through these 2 questions, 97 and 99, and you might not have had time to do 99, but I wanted to show you what's up there because you have a hard copy of what we did. Because I know what we did on the calculator for the data about number of best friends, that's hard to do that in the moment and keep pace with what we're doing. And that's what 99 is about. So 97, what do we say? How far apart were the test scores? Lowest to highest for our boy Joey was 24-point difference. When you put the 0 in there, it's a 98-point difference. So that's just showing you the range is sensitive to outliers. That 0 really affected the range. So what numbers did we deal with for those first 3 questions? The mean is sensitive. The range is sensitive. The median is resistant to outliers. So you get a question that says, like a multiple choice question, which of these are sensitive to outliers and which are resistant? That's how that would be phrased, and you have to think through this. So 99 is a different data set, but what happens is you have these screens here so you can follow what happened, what we did with the friends. So the question for 99 is, here are foot lengths in centimeters for a random sample of 7 14-year-olds. So there they are. What do? We found the mean. The mean's 24. So I did list 1, subtract 24. That's what's at the bottom of this printout, or bottom of the screen. And that's in list 2. So there are the numbers in list 2. But they're going to add up to 0. So I said list 3 is list 2 squared. And then what? The sum of list 3, the sum, which is on second stat math, but if you don't remember that, you find it in the catalog, divided by 6, which is 1 less than the data set, because we're doing the sample standard deviation. We have to take the square root of that because we squared it in list 3, and we get this number, about 2.5. Then if I type standard deviation of list 1, which will take you right to the point instead of getting all the value on stat calc. And you can get that in the catalog, but that's also in the second step menu. It's the same value. See, standard deviation on the calculator is giving you the sample value because that's the default. It's rare to have the population standard deviation, but if you know that you have it, then you would divide this by 7. I mean, ready? We don't have it. That's not all the 14-year-olds in the United Kingdom. It's only 7 of them. So we divide by 1 less than the sample size. Okay? So in this case, foot length, take away the mean, then you square it, divide by n, take away 1, you take the square root of that. So we're going to do the beta lesson tomorrow for 1-3. And we are going to send you we're going to send you the